Okay, round 2 here. Scientific notation. Okay. So, first we're going to learn about writing numbers in scientific notation. In scientific notation, numbers are always written in the form a times 10 to the power of b. A times 10 to the power of b, okay? Where b is an integer. Integer means the whole number that's either positive or negative, okay? So like -2, -1, 0, 1, 2, so on and so forth, either direction. And a has to be between 1 and 10. Has to be between 1 and 10, okay? Between 1 and 10. That means it has exactly one non-zero digit before the decimal. So we'll have exactly one non-zero digit before the decimal. This notation is especially useful for numbers that are either very small
or very big.
Or very large. Yep, very big.
Aren't they mostly used for large numbers?
Either way, they're either used for very small numbers or very large numbers.
Ah, okay.
Yeah. So, what ends up happening here, guys, is we have 1.07 times 10 to the 4th. Well, we take the number 1.07, and 10 to the 4th is 4 10s being multiplied together, right? 10 to the 4th means there's 4 10s being multiplied together. That's what we just learned exponents were, right? Multiply 4 of those together. So if we have 10 to the 4th, that's the same thing as 10 times 10 times 10 times 10. Does anyone know what our helpful rule is when we multiply by tens? Add the zeros, right? So it's a 1 with how many zeros? 4 zeros, because there's 1, 2, 3, 4 zeros. 1, 2, 3, 4. What do you say? So this is 10,000. So this is actually going to be 1.07 times 10 to the 4th is 1.07 times 10,000. That's what that's really saying. Now, what would we do if we're multiplying by 10,000? What does that tell us here? We move this how many decimal places?
170.
We end up moving it by 4 decimal places, okay? Do you guys know that trick?
Because it's 4 zeros.
You guys raise your hand if you know that trick. Raise your hand if you know the trick of moving a decimal with powers of 10. Okay, that's nobody. We'll go through it. Now I know. I mean, no, it's good to know. Okay?
Wait, are you talking about like how?
You move it to the right or the left?
Yeah.
Yeah.
Oh yeah, I do know that. I think we don't.
Yes, we do.
We do. We learned this
It's
in
all we
seventh
literally
grade,
did this
but
last year.
It's not
Seventh
that
grade,
hard.
we did not learn scientific notation. We
But we did.
In Miss Albush's class, yes we did.
How
Selfish.
wishes you
Wait, did we learn this?
No.
Oh,
Me and
my
Mr.
bad.
Wallace, did you jump
Boy,
in?
my bad.
Okay, 8th grade.
Eighth grade.
No!
Okay, guys.
Eighth grade.
Voices off. Attention up here. 10,000 times this, okay? Well, 0 times all this is going to be 0, so we can just drop these zeros, can't we?
No.
So we can drop, when we multiply 0 times everything, 0. 0 times everything, 0. 0 times everything, 0. 0. What's 1 times 7? 1 times 0. 1 times 1. How many numbers are behind the decimal point total? 2. So we have to have 2 behind. So we end up getting 10,700. Do we have to put the point 0, 0?
Yeah, no.
Oh,
No. So we end up, let's write that out, let's forget. So we said this, 1.07 times 10,000, which we did over here, ends up being 10,700. So essentially, what happened, guys, if we look at this, what essentially happened here was we ended up moving this number, this decimal, this 1.07, this decimal right here. If we took 1.07 and we moved this decimal 1, 2, 3, add a 0, 4 times, did we get the same number? If I took that decimal and I moved it 4 times, filling in zeros where we need to, where there's a new spot, we got the same number.
yes.
Okay? And that's what 1.07 times 10 to the 4th ends up equaling, is 10,700. The same thing would be true for this.
So
For 1.07 times 10 to the 3rd, let's look at that. Okay? Well, 1.07 times 10 to the 3rd. Well, that's going to be a 1 with how many zeros behind it? 3 zeros. It's going to be 1 with 3 zeros. Let's look at that again so that we know. 10 to the 4th was 10 times 10 times 10 times 10. 10 to the third is going to be 10 times, how many tens we multiply together? 3. And what's our trick with multiplying by tens? Add zeros. So how many zeros are there? 3. So it's a 1 with 3 zeros. So we end up getting 1.07 times 1,000. We go over here and do this math again. 1.07 times 1,000. The zeros, we can drop them again, because 0 times everything is 0. 0 times everything is 0. 0 times everything is 0. What's 1 times 7? 1 times 0. 1 times 1. Two numbers behind the decimal, 2 numbers behind the decimal. You don't need those. 1,070. So we end up getting 1,070. So how many spots would we have moved this decimal over? 1, 2, 3. 1,070.
Big
Are we
brain.
noticing a pattern?
Position your.
Presley, do you notice a pattern? Find out what kind of pattern are you noticing?
You just take away 0 every time.
What do you mean you take away a
You
zero?
really just remove
Yeah,
the
like
decimal
when you
points that the
do less
exponent.
zeros, you don't move by many decimals.
Okay. So the less zeros we have under 10,000, the smaller the power of 10, the less we move it. Okay. So if I do 1.07 times 10 to the second here, so if we do this one, 1.07. Jeepers, my pen is second here. 1.07 times 10 to the second. Well, 10 to the second is how many tens? 2. So that's 1 with how many zeros? 2. So that's 1.07 times 100. What to figure out that is, let's go over here again. 1.07 times 100. Zeros, well 0 times everything is 0. 0 times everything is 0. 1 times 7 is?
0.
1 times 0 is?
0.
And 1 times 1 is?
1.
2 numbers behind the decimal, 2 numbers behind the decimal. 107.
Wow.
2, okay, 107. In order to take 1.07, how many numbers would I move the decimal spot? 1, 2. Now, are we noticing how many numbers did we move the decimal spot here? 2. How many zeros did we have? 2. What was the power of 10? What was the power of 10 we multiplied by? 2. In the green, how many numbers did we move? How many spots did we move the decimal? 3. How many zeros were there?
2.
How many zeros are there?
3.
Oh, 3. What was the power of 10?
3.
Here, how many spots did we move the decimal?
4.
How many zeros were there?
4.
What was the power of 10?
4.
Are we noticing a correlation between the power of 10 and how many spots we move the decimal? What's the correlation or the relationship we're noticing?
They're the same.
They're the same. So, how many spots do we think will move this decimal? 1.07? 1. And hey, what happens? 1.07 becomes 10.7. How many spots do we think will move the decimal here?
None. Don't.
0. You don't. And look, we didn't. Another thing here is, what is anything to the power of 0?
Same.
What's anything to the power of 0? Dalton said 1. 1.07 times 1 is 1.07. It's the same. That's why you don't move it at all. And then we can keep going down, and the negative exponent is 4, 3, 2, 1, 0, negative 1. Negative 1 is going to tell us to move our decimal 1 spot the other direction. It's going to tell us to move it 1 spot the other direction. So instead of moving it to the right, like we have been, instead of moving our decimal to the right, we're going to move it to the left. Like what happens? We move it to the left. Negative second, and then the negative second, we're going to move it how many decimal places?
2 times.
2 to the left. 1, 2. 1, 2. We had to add in zeros there. How many times do you think we'll move it here?
4.
4 to the left. Negative, you mean to go left. Think of a number line. Negatives on the left, positives on the right. Okay, negatives on the left, positives on the right. Okay? That's how many times we move the decimal. How many times we move the decimal from where it was originally, okay? Now the reason why, first of all, before I erase this, does everybody understand the blue, green, orange comparison I just did here?
So
Raise your
it
hand if you don't understand that. Okay.
doesn't, so So it doesn't matter if you have like that 7.
What do you mean? That's 7.
Like in the green problem, do you see where? Yeah. So
I have a 7 here. Is that what you're asking about?
yeah. So you not like I don't know how to explain what I'm asking. Never mind. I'll just figure it out. No, I think I've answered it. But
Okay.
does 7 count as like a digit and
Yeah.
like the oh?
That's one of the decimal spots you move.
Okay.
Because you move from here, you move to 3, 1, 2, 3.
So it doesn't matter which digit.
1 to 2. It doesn't matter whether it's a 1, it doesn't matter whether it's a 5, it doesn't matter whether it's 7 or a 0. We're going to move it a spot. Okay. What is 10 to the negative first? 10 to the negative first, what's that mean?
So go to the decimal 2 times to the left.
So if we had 1 time to the left, it's negative first, but 10 to the negative first is the same thing as 1 over what?
10 to the negative.
1 over 10 to the first, or 1 over 10. The negative exponents mean you send them downstairs and they're upstairs, right? That's what Sergey told us earlier. Okay. So 1 over 10, what would that 1 over 10 be in decimal?
It would be 0.10.
0.1, yeah. Because 1/10 is 10%. 0.1, you know, think about it this way. If I were to take 10, or excuse me, I take 1 divided by 10, I'd have to add the decimal, right? We talked about that before. How many times does 10 go into 10? Once. So it ends up being 0.1. So 1/10 is 0.1. Okay? So if I do 1.07 times 0.1 for my 10 to the negative first here, I'm doing 10 to the negative first here. I go over here and I do that, 1.07 times 0.1. Well, what's 1 times 7? 1 times 0. 1 times 1. And then 0, 0. How many numbers are behind the decimal? How many numbers do I have to have behind the decimal?
3.
So I end up getting 0.107. How many times did I move the decimal this time? 1, but where did I move it to? The left. The number got smaller. The number got smaller. So I go through and I do it in with the next problem. 1.07 times, okay, well, let's figure out what's 10 to the negative second. So 10 to the negative second is the same thing as 1 over 10 to the second, right?
Yes.
Or 1 over 100.
Yes.
1 divided by 100. Well, we can do that math just like we did here. 1 divided by 100. Have to have a decimal point. We're going to have to add 2 zeros here. How many times does 1 go into 100? Once. And that is 100. So we end up getting 0.01. Notice, are we just putting more spaces to the left there? Or is it getting a smaller decimal each time? We had 0.1, 0.01. So we end up having 1.07 times 0.01. Let's figure out what that is. Let's go over here again. 1.07 times 0.01. What's 1 times 7? 1 times 0. 1 times 1. 0 times 7? 0 times all that 0, right? How many numbers are behind the decimal here, guys? 4. How many numbers do we behind the decimal? 4. That's how we get 0.0107. .0107. How many numbers did we end up really moving this decimal this time? 2. But as you move it the second time, you have to add a placeholder there because there wasn't one. Are we seeing this pattern?
Yes.
Okay. So with the negative exponents, we just keep getting one decimal smaller. Presley. It's a great question. Great question. Presley asks if anyone didn't hear, okay, or if the video doesn't hear, okay, is Mr. Kossel, you're a real G. I'm like, oh, thanks, Presley. Okay, I don't know if you guys heard that interaction, but it happened, okay.
I don't care.
Mr. Kossel, you're, well, it's on the video now, so it happened, okay. Mr. Kossel, you're a real G. Thank you. Okay. I'm like, oh, thanks, Presley. I know. You too. She's like, oh, thanks, you know. Okay. And I'm like, okay. She's like, hey, so, real G. I'm like, yeah. And she's like, so, do we have to go through this whole process each time? Or if we notice this pattern, can we just move the decimal? Can we just start doing that? Yeah, you totally can. That's the beauty of scientific notation. That's the whole beauty of scientific notation. That's why we like it, is because it makes our life way simpler of just saying, instead of saying we have this huge number, we have to write out all these zeros all the time. Like if, like for this example, down here, 1.07 times 10 to the negative fourth, do any of us really want to write out all those zeros and count them all the time?
No.
Probably not. So what we do is we say this instead. And we just know this is this number with 4 decimal spots moved to the left. Does that make sense? That's a great question. I'm so happy you asked that. Okay? So something I want us to note here, guys, and this is something I actually want you to write down on here.
Oh, that's what.
If it's negative, it goes to the left. Right? This is what happens.
Okay? So I want you to write up here. Why is this not clicking? For these numbers here, the exponents are positive, aren't they?
Yep.
1, 2, 3, and 4 exponents are positive, okay? So I want you to know that the positive exponents, they make the number, what? They made this number 1.07, what did they do to it?
Bigger.
Bigger, they make the number bigger. What did the negative exponents do? Make the number smaller. The negative exponents they make the number smaller. What did the power of 0 do?
Nothing.
It stayed the same, didn't it?
Yes.
Right? Because 10 to the power of 0 is secretly what number, guys?
1.
1. And anytime you multiply by 1, it stays the same, right?
Yes.
Okay? So it stays the same. Okay, positive exponents, gonna make the number bigger. Negative, gonna make it smaller. 0, stay the same. Questions on that? Okay. So we're gonna practice moving some of these numbers. So if we have the number 52, we're gonna practice writing that in scientific notation. So what we said is we want the number we only want one number in front of the decimal. We only want one number in front of the decimal. How many numbers are there secretly in front of this decimal here?
2.
2, because this is really 52.0 or 52 point something. Okay, 0.00000. So right now we want, how many spaces are we going to need to move this decimal?
Oh,
1. We need to move this decimal 1. We need it to be 5.2. Because we're going to say it's 5.2 times 10 to the, well, to go from 5.2 to 52, if to go from 5.2 to 52, how many spots would we have to move it? 1. So it's 5.2 times 10 to the first. It's 5.2 times 10 to the first. Because to get it back to 52, we'd have to move it 1 spot to the right. To get it back to 52, we'd move it 1 spot to the right. On example 2, anybody have an idea of what we have here? Okay, anybody go ahead. Dylan, head up.
8.452 times 10 to the 3.
8.452 times 10 to the third. I agree. We want to move the decimal here, so that way it's only one number in front of it. So we do that. And Levi said, how many spots did I move it? 1, 2, 3. Okay. So how many spots would I have to move this back? 1, 2, 3. So 10 to the third. Okay. And I'd have to move the number. Back to the right. So it's a positive exponent. Okay. One way to think about it is our actual number bigger or smaller than our decimal? Our actual number is bigger, so it has to be a positive exponent. Okay? I want you guys to try number 3.
Oh, we have to write the whole number out then.
You have to write everything but the last 0.
Okay.
Yeah, because otherwise it's a different number. Okay? Once you have it or have questions, raise your hand.
Mr. Paso. Cool.
I got you. Mr. Possible.
What?
Like it kind of like just like stops.
Oh, yeah, I remember.
Yeah,
Is that it?
That's weird. Yeah, like, it looked like you had 2 layers.
Yeah, like I have like so like my normal hair right now is a little longer than normal than I usually have it, and so it's like going like over my beard a bit.
Do you cut your sides?
I trim it, yeah. Trim all of it.
You started it up.
So where do you want the decimal?
That's the match.
1, figure 2, figure 3, figure 4, figure 5, figure. Make it dog.
Fingers is what number it is.
Had number 4 done.
I'm not inviting you in real life.
Alright, so we end up moving this 1, 2, 3, 4, 5, 6, 7, 8 spots. 2.4, 8, 3, 1, 2, 4, 5. We don't actually need that 0. You don't actually need that 0 times 10 to the 8th. Because here's the thing. If we were to move this back, if we were to move it back afterwards, we'd add back in the 0, so we're not concerned with it. But we do need all those other numbers because if we don't have those other numbers here, guys, like if I, for example, were to say this is the same thing as 2.48 times 10 to the 8th, and I were to go out and actually move the decimal again, 2.48, and I move the decimal 8 times, 1, 2, 3, 4, 5, 6, 7, 8. I'd fill these in with zeros. And is this the same number as what we started with?
Pretty much.
No. That's why we need the actual numbers there, but we don't have to worry about the ending zeros. We don't have to worry about the ending zeros. We call them the trail zeros, so to speak. Okay, the zeros that trail everything else. Okay? Let's try number 4. You guys try number 4.
I'm done.
Once you have or have questions, raise your hand.
You don't make dad jokes then.
Can you look at
I
mine
know,
first?
Mr. Constance again. I know, Mr. Constance again. Like, so close to me. I don't remember. Very good, don't check.
I'm at negative 2.
Very good, don't check.
Yeah.
Very good. Don't check. Yeah.
Come on.
There you go. And that was.
Why does it
Okay.
seem like the light out? There's like dark.
So, how many spots are moving decimal here?
I can't
2, 1, 2. So we know it's going to be 4 times 10 to the something second. But which way are we going to have to move our decimal now to get it back?
Negative.
We have to move it left, so we'd have to make it negative second. Is our original number smaller or bigger than 4? Our original number is smaller than 4. Our original number is smaller than 4. So we have 4 times 10 to the negative second here. Well, you guys try number 5.
I'm
If you
done.
don't have or have questions, raise your hand. I agree with you, check. Alright.
Sorry, Greg. I need a haircut.
Oh, mine is about release. This isn't it.
Oh,
So
why?
I go.
I see how we are.
Need a haircut.
Look at mine.
I don't know, I didn't check it.
If you read this, but we need to read this, so.
Oh, you
Ray,
can do
you're
that.
big trash boy.
I'm joking.
Yep, yep, just like we did. take this number and look at 7 more.
Dylan, you're wrong.
Fail on
That's
that.
big, easy.
You don't have to have any of those zeros.
Think about your mom asked me
Maybe
to
give
go
us
on
that
a
8 plus 8.
She always.
Does that make sense?
She's like, you're like,
I told her I'd send you a picture.
So, Surrender, what did you get? 8.8 times 10 to the negative second, okay? What we have to do is we have to move this decimal 1, 2, 3, 4, 5, 6, 7 times. One number in front of it. Okay? And we do not need all these zeros in front because what's going to happen is that as we try and move it back, if you were to try to move it back and go the other direction from it, okay? You take 8.8 and you move this 7 spots left. 1, 2, 3, 4, 5, 6, 7. And you would naturally fill these in with zeros.
Wait.
So you don't have to worry about it. Okay? Now number 6. This one's a little tricky. Can anybody tell me what we think we'd have at number 6?
I got it.
Levi.
2.0008 times 10 to the negative fourth.
I agree.
I agree.
2.03 times 10 to the negative 4. Okay? So we have to move it 1, 2, 3, 4 times.
No.
And we need these zeros here. The reason we need these zeros here, we didn't need the 0 here before on 3 or the zeros on 5, is because there's a number behind it. They're not trail zeros. They're kind of sandwich zeros to think about. They're kind of sandwich zeros because they're sandwiched between 2 numbers. Because we need to know that there's a different distance between the 2 and the 8. Some of us might be tempted to just have 2.8 times 10 to the negative fourth, for example. What you have here is you have 2.8 and then you move the decimal 4 spots, 1, 2, 3, 4. And 0.00028 is not the same thing. Okay, so you have to be careful we have any sandwich zeros there. Question on that?
No shit.
No, sir.
Thank you, and Linda. Let's flip the page here, okay? Okay?
You might know how to do these.
It's not a fourth yet.
these are easy,
Okay.
easy.
Let's try number 1 here. We're going the other direction now. We started scientific notation, we're going the other direction. Okay?
Yeah.
Once you have number 1 or have questions on it, raise your hand. Once you have number 1 or have questions, raise your hand. You want to have a check? You want to have a check?
I got it.
Okay, do you want to have a check? Go.
Mr. Costco.
Okay. Go.
Actually,
Yes,
no, right.
Mr. Costco, look at mine.
Someone got it.
Can you check mine, please?
There you go.
Yeah.
Oi.
Mr. Carlson, what are you doing?
Yes.
Yeah.
Once you finish number 1, I actually want you to go on to number 2 and 3 now. Go ahead and go on to number 2 and 3.
You can make like a bow and arrow out of those pencils.
Yeah.
Levi, you told me you'd
Yes.
make me one. No, I didn't.
Oh wait,
I never said I'd make you one.
you said you made one.
Those two?
Yeah, if you gave me a pen.
This is 1. That's 1. Is that enough? Okay, and then you want to check those?
I'm just gonna make it darker.
Geez, move your blood with these.
Very good. Okay. I want you guys to go ahead and try 4 through 6 now. Go ahead and try 4 through 6 now.
Jane, wait.
4 through 6.
Down to the socks. I told him baby.
Mr. Costco, can you come look at this now? Because I finished.
You want to check?
I can do days.
Oh, wow.
I can do days.
Every time you asked her, she said no.
I know. It's not cool. What's this one?
Right there, and it's right there, and it's right there.
Or I agree with this one.
Okay.
It'd be a young boy's
You
child.
can make it
This one. I don't think it's strong.
What about this one?
This one, we'll check.
Yeah, sure. Hey,
Great.
Joe, go to check. How
Yeah.
many zeros are we?
7.
Sure.
Wait. What was it?
No, but yes, okay.
Oh, God. Hey.
What was that for?
Ontario. Wait, what did you just say?
Yeah.
So I think you already
Wait, how many zeros are there?
Yeah, but you need to put decimal.
You need that. And one less five. Wait, never mind. Not one less.
I miss you.
What?
Alright, anybody have any questions on these?
No, sir.
Okay, I'm just gonna go through quickly and write the answers then, since we all had them though.
Can I-
42,030, 320,000, 3.14,
Wow.
0.0188, 0.1234 zeros, 5, and then 0.123456 zeros, 5. Okay, continue on right below this guy, right below this guy.
Do we have
Okay?
more?
We're gonna speed right in that section, okay? Multiplying and dividing in scientific notation. Okay, we have a process we're gonna do here, guys. We have a process we're gonna do here, and I'll explain why it works this way, okay? So, we're gonna group the numbers together and group the powers of 10 together. We're gonna group the numbers together, we're gonna group the powers of 10 together, okay? So if we have 2.0 times 10 to the 5th and 4.0 times 10 to the 4th, we are saying everything's being multiplied together here, because we have multiplication symbol right here in the middle. So, we can rearrange the order we multiply. We said the order we multiply things does not matter. We can multiply things in any order and it's fine. So what we're going to do is we're going to rearrange this. So I'm going to put 2.0 times 4.0 in one parenthesis. I'm going to put 2.0 times 4.0 in the parenthesis. I'm going to put the normal numbers together. Then I'm going to put 10 to the 5th and 10 to the 4th together. We're going to put 10 to the 5th and 10 to the 4th together. Okay. Now, once we have these grouped, I think it's a lot easier to see how to multiply these.
Sir.
What is 2 times 4?
6.
Because 2.0 is 2, 4.0 is 4.
Oh.
2 times 4 is 8. So this is 8.
I'm so happy to be
10 times 10 to the 5th and 10 to the 4th, do those have the same base?
Yeah.
So what can we do with the exponents? Like Kari said a moment ago, add them. So we have 8 times 10 to the 9th. Is our answer already in scientific notation? Yeah, because we have only one number before the decimal. 8 times 10 to the 9th, we're good. We can leave it there because
That's all it
we're asked to write our answer in scientific notation. We're asked to write our answer in scientific notation. So this is the one time I'm okay with us not actually writing it all out, because we're specifically asked to use scientific notation. Can I have you guys try number 2?
Yes, sir.
Following the same pattern. Okay? And be careful, you might have to move it to scientific notation afterwards. Okay? So that's almost right. Good. We'll have one more step after that. Yep, one more step after that. Very good. That's where I expect you to be. Okay, one more step after that. Very good. Okay?
Someone wants to play the equals.
What?
One more step
Levi,
after
you're
that.
trash at equal.
How many would you have?
Well, okay, yep, well, one more step after that. Very good. Okay.
27.
That's it.
About 27.
Oh.
There you go.
What do you mean
One more
that's
step
it?
after that. Okay?
27 wins.
I don't know like 8 ball, but
I don't know like Fortnite. Boy.
Okay.
What's up, Chase?
Alright. So, guys, what we do is, as you guys had, we have 3 times 5 in one parenthesis. Voice it off, guys. Times 10 to the 2nd in the other parenthesis, and 10 to the 6th. Well, the parenthesis on the left, 3 times 5 is 15. Parenthesis on the right, 10 to the 2nd, 10 to the 6th. Add the exponents because it's the same base. 10 to the 8th. Now, wait a second. Is our answer in scientific notation right now?
no.
No, because we have 15. There are 2 numbers in front of the decimal. We want 1. So I have to make this 1.5. And so if this number is going to get smaller, I'm going to make this number 1 bigger.
Oh.
10 to the 9th. Because I'd have to move it 1 more decimal point to the right to get it back to 15, wouldn't I? Okay? That's another way to think of these guys. If the number gets smaller, the exponent gets bigger. If the number gets bigger, the exponent gets smaller. Okay? That's another way we can think about it. It's kind of like a balance. Okay? If one of the numbers gets smaller, the other one has to get bigger. If one of them gets bigger, the other has to get smaller. They have to stay perfectly balanced. Just as all things should be, like Dano says. Okay? Questions on that?
No, sir.
Okay, let's try number 3 here. 2.5 times 4. And then we have 10 to the negative 3rd times 10 to the 4th. Well, 2.5 times 4, what is that? Anyone know? 10. What if you have What if you get paid $2.50? Maybe you get paid $2.50 every hour. Let's say it's a really cheap wage, really bad wage. And you work for 4 hours. How much are you making? $10. Let's say you buy 2 things. Let's say you're buying a Gatorade for $2.50. And you buy 4 of them. How much are you spending? $10. So it's 10. Think of it in money that can help us. 10 times 10 to the, well, negative 3 plus 4 is 1. 10 times 10 to the first.
Wouldn't it be 1.0?
Very good. And then we make it 1.0 times 10 to the second. That's exactly right, Levi. We have to move it one more time. And because we make the actual number smaller, we make the exponent 1 bigger. Because we make the actual number smaller, we make the exponent 1 bigger. Questions on that?
No, sir.
Okay, the same thing works for division. Notice here, between our parentheses, what operation do we have? Division. So here's what's going to happen, guys. We're going to group our normal numbers together, the 8 and the 4. What symbol is going to go between the 8 and the 4 now? Division. And we're going to group the powers of 10 together, but there's going to be a different symbol that goes between them.
Yes.
What do we think it's going to be? Division.
So it'd
So
be
you have to be careful, because whatever symbol is here is what goes between the parentheses. Whatever symbol is there is what goes between the parentheses, okay? Because we have the multiplication on 1, 2, and 3, we put multiplication in the middle of the parentheses. Between the regular numbers, between the powers of 10. So here it changes.
it'd be 10 to the.
So what's 8 divided by 4? 2. Now we still have times 10 to the power of. What do we do with this power of 7 to the power of 3? Subtract, so 10 to the power of. So 2 to the power of 4, and that's in scientific notation already. Does that make sense?
Yes.
Was that too scary? Okay, I didn't think
It's
so.
weird at first.
It's weird at first, right?
Wait, so we don't have to write it in
Standard form?
yeah.
No, because we're specifically asked here, write your answer in scientific notation. So that's why we leave our answer like this. That's why we had to change 2 and 3 as well. So here, can somebody tell me what we do on number
4.5 divided by 1.5.
Yeah, 4.5 divided by 1.5 in the first parenthesis.
And then 10, 7 divided by 10 negative.
Very good. Now we actually do these problems. What's 4.5 divided by 1.5?
Something 0.5.
If something costs
3.
3, okay? 1.5 goes into 4.5 3 times, okay? Let's say you're buying 3 things for $1.50. One ends up being $4.50. 10 to the 7th divided by 10 to the negative second is 10 to the
9.
9.
What?
7 minus negative 2. We subtract them. 7 minus negative 2. You have 7 minus a negative 2. Minus, add. 7 plus 2 is 9. 3 times 10 to the 9th. Okay? Here on this last problem, what numbers are we going to group together in the first parenthesis?
7.0 divided by 3.5.
7 divided by 3.5 or 7.0 divided by 3.5. Second parenthesis,
10 to the power of negative 6.
Yep.
Divided by 10 to the power of negative 6.
very good. You guys are doing a very good job of making sure we have the right sign between the parentheses in the middle. 7 divided by 3.5. 2. 2. It's half good. Times 10 to the, negative 6 divided by the 10 to the negative 4th. Okay? It ends up being 10 to the negative 2nd. If you need help with that, write negative 6 minus negative 4 plus negative 6 plus 4 is power of negative 2.
Too easy.
Questions on that?
No.
Okay? So, guys, on your homework for this, it's going to be mixed up. You're going to have some multiplication, you're going to have some division, okay? You have to be very careful with your signs. You have to be very careful with your signs.
Hey, wait, do you listen to ASAP Butler?
No!
At legal?
No.
That's illegal.
This is Larson.
Feel like your dowel's falling down.
Wait, doesn't Mr. Larson's wife like wrestling? What? Mr. Larson's wife, she likes wrestling?
Yeah, he's missing one.
Yeah, that's weird.
I can see that.
I would not let my wife.
Oh.
I can see that.
you gonna let your wife dress you?
We're working on a negotiation on it.
Do
Wait,
you want her
really?
to dress you?
So no.
Does she want
I
you?
low key think I have better
Yo,
style than she
Matthew.
does.
Yeah.
I'm better with colors than she is.
Dowel fell off. My dowel fell.
My mom dressed my dad.
Hey guys, on this worksheet. Hey. Oh yeah. Hey guys, on this worksheet. Okay. On this worksheet, guys, listen up. Listen up. Look at numbers 19 through 22. Look at numbers 19 through 22. Okay, that's supposed to be a division symbol between the two problems. Okay, between the two parts. So hey guys, just like here on this example on the board right now, we had 1 through 3 were multiplication, and then 4 through 6 were division. Okay, on 13 through 18, those are supposed to be multiplication. 19 through 22 on the worksheet here are supposed to be division. Okay, so like for example on number 19, it should look like this: 6.6 times 10 to the third in parentheses being divided by 1.2 times 10 to the negative third.
Wait, you got me mixed up.
Okay, so in 19, it's supposed to be division. So we're supposed to have the first scientific notation, second scientific notation for the division symbol between it. Does that make sense?
Wait, so 13 through 19.
13 through
We
18
do all.
are multiplication.
What?
19 through right, like up here. 19 through 22 are division.
Okay.
We do all.
Alright, man.
You don't have to do the back though.
Ah, you're funny.
Serenity smile, I'll count that as a win. She thought it was kind of funny.
Maybe automatic. Count and multiply. Levi, play that song right now. It's on SoundCloud.